Did you ever wonder what would happen if the continents kept moving, and one day, Australia crashed headlong into Asia? That isn't just a wild thought experiment. It's the scientific forecast at the heart of will Australia collide with Asia and create a new supercontinent? Right now, Australia is drifting north faster than almost any landmass on Earth. So quickly, in fact, that GPS maps have had to be reset by nearly 2 meters in a single leap. If this unstoppable journey continues, it could trigger mountain ranges to rival the Himalayas, remake the climate, and fundamentally reshape human life. But how do we know this collision is coming? And could it already be changing the world beneath our feet? In 1912, a German meteorologist named Alfred Wegener stared at maps and noticed something odd. South America's east coast seemed to fit against Africa's west, almost like pieces from a long-lost puzzle. But it wasn't just the shapes of continents that caught his eye. Fossils of the same ancient fern, Glossopteris, turned up in rocks from Brazil, South Africa, India, Antarctica, and Australia, even though those places are now separated by entire oceans. These weren't tiny seeds that could drift on the wind. They were heavy, rooted plants that grew in thick forests hundreds of millions of years ago. The same story played out with extinct reptiles like Mesosaurus, whose remains appeared on either side of the Atlantic, despite being freshwater creatures that couldn't have crossed salty seas. Wegener gathered these clues and proposed a radical idea. The continents had once been joined together in a single supercontinent he called Gondwana. His theory of continental drift was met with disbelief and even ridicule. Critics demanded to know how massive continents could plow through solid rock, and since Wegener couldn't explain the mechanism, his idea was dismissed by most geologists. Yet the evidence kept piling up, matching coastlines, identical fossils, and ancient rocks that lined up across continents like pages from a torn book. While Wegener's vision was rejected in his time, those lost supercontinent clues would eventually change the way scientists understood the planet's restless surface. In the mid-20th century, a new chapter opened in Earth science. Oceanographers began mapping the seafloor, uncovering vast mountain chains called mid-ocean ridges that stretched for thousands of kilometers beneath the world's oceans. These ridges weren't just underwater scenery. They revealed a hidden process. Rocks on either side showed symmetrical bands of magnetic stripes, each band recording the direction of Earth's magnetic field at the time it cooled. This pattern, first recognized in the early 1960s, matched the timeline of known magnetic reversals and provided the first hard evidence that new crust was being created at the ridges and pushed outward, carrying continents with it. British geophysicist Dan Mackenzie and French researcher Xavier Le Pichon took these discoveries further. By 1967, they had built the mathematical framework of plate tectonics, showing how rigid plates move as units over the globe's surface. Their models explained not just the movement of continents, but also earthquakes, volcanoes, and the formation of mountain ranges. The theory was no longer speculation. It could be measured and tested. Today, Australia's movement is tracked with remarkable precision. Geoscience Australia monitors the continent's position using a network of GPS stations, revealing that Australia shifts northward by about 7 centimeters every year. This isn't just a scientific curiosity. In 2017, the entire country's official coordinates were shifted 1.8 meters to keep maps and navigation systems in sync with reality. A logistical feat known as GDA 2020. The ground underfoot may feel solid, but the numbers tell a different story. Australia is on a relentless journey north, and now every centimeter is accounted for. Australia's northward push doesn't just redraw coastlines. It sets up a collision of continents that will reshape the world. With the continent barreling toward Asia at 7 centimeters each year, geologists predict a meeting point within the next 50 to 200 million years. When these two landmasses finally meet, the impact will be anything but subtle. The force of the collision will crumple the crust along the boundary, driving up new mountain chains that could rival the Himalayas in height and scale. Models suggest crustal thickening may reach 40 to 75 kilometers, with peaks soaring above 6,000 meters. This isn't a single ridge, but a sprawling belt of uplift, stretching for thousands of kilometers, where Australia's leading edge grinds into Southeast Asia. The slow-motion crash will trigger earthquakes, volcanoes, and the birth of a mountain range that could one day tower over everything on the continent today. Earth's continents have never stood still. Every few hundred million years, the planet's surface rearranges itself, gathering scattered land into a new supercontinent. Scientists now debate what shape the next one will take. Some models predict Amasia, a vast landmass stretching over the North Pole, where Asia and the Americas fuse as the Pacific Ocean disappears. Others imagine Orica, a supercontinent forming closer to the equator, after both the Atlantic and Pacific close, and a new ocean opens along what is now Central Eurasia. Each scenario would redraw the world's map in ways that dwarf anything seen since the breakup of Pangaea. With continents clustered together, ocean currents would be forced into new paths, and climate belts would shift dramatically. The world's deserts, rainforests, and ice sheets would all soar or vanish as the new supercontinent changes wind patterns and rainfall. The assembly of Amasia or Orica would silence familiar oceans and raise new mountains, while vast inland regions would likely become dry and inhospitable. These planetary makeovers have happened before, but the next one will create a world unrecognizable to us today. A single landmass dominating the globe, surrounded by a super ocean, and setting the stage for a new chapter in Earth's ongoing story. Australia is moving north at a rate of about 7 centimeters per year, a speed confirmed by decades of satellite and GPS measurements, and enough to require a national GPS coordinate update in 2017. Fossil records and matching coastlines proved that Australia was once connected to Antarctica in the supercontinent Gondwana, before breaking apart approximately 100 million years ago. Today, geoscientists agree that if current tectonic trends continue, Australia could collide with Southeast Asia within 50 to 200 million years, potentially forming a new supercontinent such as Amasia or Orica, and raising mountain ranges as high as the Himalayas. While the precise timing and ultimate shape of the next supercontinent remain uncertain, the evidence is clear. Earth's continents are in constant motion, reshaping global climate and ecosystems. This ongoing drift influences everything from navigation systems to long-term planetary cycles. The story of Australia's journey, recorded in rocks and tracked by satellites, reminds us that the land beneath our feet is never truly still, and that the future of continents is written in the movements we can measure today.